In the next video, I will try to tackle the classic machine learning game, Flappy Bird. So stay tuned. Flappy Bird, Flappy Bird,
Flappy Bird.
Shoot. Shoot. Crap. Where'd the ground go? Well, that's not how gravity works. Well, alrighty then. So, I know I was supposed to do Flappy Bird this video, but as you can see, that might take me a while. I promise I will get the video out eventually, but for now we are going to do something a little bit different. I'm going to make a pathfinding algorithm. It is an AI that will dodge obstacles and find the shortest path to a destination. So, does this use the genetic algorithm or neural networks? Well, neither. It uses what is called the A-star algorithm. I'm confused. What's the difference between algorithms, AI, and machine learning? Why, I'm glad you asked, PassCam. I can see how it can be a bit confusing. You can think of all three terms in one of these three circles. Algorithms are a set of instructions or formulas to follow. You are telling the computer to do this, then do this, then do that. For example, I'm going to create a quick algorithm that will take a formula you give it, plot it, and find the zeros. I told it to create a table plot of corresponding x and y values, draw a dot on them, and if the y value is 0, then draw a red circle on it and print the values. See? We just successfully made an algorithm that can factor. Take that, Algebra 2. AI is something that can make decisions. Although AI can be very broad, the best way to describe it is something that can think for itself. For example, an algorithm could be used to, say, jump or don't jump. The algorithm could calculate the distance between the dino and the cactus, and if it is within a certain distance, it'll jump. I think I just come up with another video idea. But anyway, machine learning is a form of AI. Instead of manually writing the code for the AI to, let's say, tell the dino to jump, it'll do that on its own using various algorithms. Common AI algorithms include NEAT, which stands for Neural Evolution of Augmenting Topologies, which is primarily used for neural evolution, Cadenay's algorithm, which takes an array and finds out an array subset that produces the highest sum, or this, A-star pathfinding algorithm. Its goal is to dodge obstacles and find the shortest path. Okay, quick explanation on how it works. So you have a starting position and a target, and some barriers in between. It works on a grid system. It first determines which nodes are open and closed. It's closed if there is a barrier there and open if it's not. It then calculates three values for each node. The g-cost, which is the distance between the current node and starting position, the h-cost, which is the distance between the current node and the target position, and the f-cost, which is the h-cost and g-cost added together. It figures out which f-cost of the surrounding nodes is the lowest and then makes that node its current position. It continues to do this until it's made it to its destination. Woo! Alright, let's get started. First, let's create a grid. Like I said, the algorithm works on a grid system. I couldn't imagine if you had to check every pixel. That would be a mess. Secondly, let's make it so we can draw barriers by holding down the mouse. I want it to only draw within the grid though. Well, it seems to be a bit reluctant to draw for some reason. Okay, so my current method for drawing definitely is not working, so let's try to tweak it a bit. Let's write a short algorithm that will round the mouse positions rather than give it strict requirements like I was doing before. There we go, that's much better. Okay, now let's write the code that will generate the positions we need and find the g-cost, h-cost, and f-cost.
My code isn't efficient at all.
Shut up, console nerd, I'm trying here. I know this definitely is not the most elegant code you've ever seen, but hey, this is the best I can do. Take it or leave it. As you can see on the bottom of the screen here, it has successfully generated the local f-cost. Okay, now that I have successfully gotten it to generate FCOS, it is time to implement some movement. Now, let's make it so that it'll see which direction to go based on the FCOS value. It'll find the shortest path to its destination and well, alright, let's just make a couple of changes to the algorithm. I guess now would be a good time more than ever to mention what happens when two FCOSs are the same value. It spazzes out. But in actuality, it should then look at the HCOS and figure out its lowest value and pick that one. And now, as we can see, success! Oh yeah, this coding challenge is complete. Cue the end card.
But Cam,
Not now, comp sci nerd. I'm too busy celebrating. Hit it.
you haven't added any barriers yet.
Psh, who cares? Barriers, schmarriers. It'll go around those barriers like it's nothing. Oh, crap. Darn. Darn. Crap. Just go around it. Ugh. Okay. So the issue is, it only looks at the FCOS that are immediately surrounding it. So if the 8 around it aren't viable, then it'll, well, you know, which is no good. So we essentially need to start the algorithm over and rethink our approach. Welp. Okay, I'm going to start on a larger grid and get the FCOS of every node in the map. Using the larger grid just makes it easier to troubleshoot. I'm also going to print them so that I can see what they are. And okay, great. Even though that kind of looks like... Okay, let's spruce this up to make it a bit more appealing to the eye. Then we can recreate what we did beforehand, but this time put it on the new grid size, as well as add some modifications. And let's make the path red so that we can clearly see every node that it's been to. And perfect, that looks good. Now let's tweak the barrier placing algorithm so that we can place barriers on the new grid. Perfect. And now we get to see all of the FCOS. Now let's just let it find the path and...
You're not very good at this, are you?
Leave me alone. Okay, let's make some adjustments to ensure that it's not crashed this time. And woo, it did it. Now for the moment of truth. With barriers. Awesome. All right, let's go. Now, let's just implement these changes onto the regular size grid and add some slight modifications. And oh yeah. Now, lastly, let's add the infamous vertical wall of doom. Alright, I know the path doesn't look great, but I will just declare victory now. Let's give it one more super complex one. Awesome. Well, this is probably the best it's going to get, so I'm just going to walk away now while I still have a piece of my dignity left. I want to thank you all for watching the video. I promise I will get the Flappy Bird video coming eventually. Not sure when, but I doubt it will be the next video, so don't hold your breath. But it will happen one day. It was much more complex than it should have been, so it might take me a while, but it will come one day. Eventually. But again, thank you all for watching. I am hoping to continue to upload on this weekly or maybe bi-weekly basis, but it should be still fairly consistent. Like, comment, subscribe, all that good stuff. Stay safe, and I hope you enjoy the rest of your day.